So hey guys, today we're going to be looking at the HSC Physics examination for 2019. The reading time is 5 minutes, the working time is 3 hours, but that doesn't really matter because we're just kind of going to go through it, see some exam style questions that we can answer together, and I'll give you a quick explanation for each one. So just in this episode today, we're going to be looking at the 20 multiple choice questions, and then in the later episodes, we'll be moving on to a few questions from the short answer each, maybe one, depending on the length of it and the complexity. So this first question should be quite easy. A projectile is launched by a cannon as shown. So just a ball coming out of a cannon with a certain velocity in the x direction and the y direction. Which arrow represents the velocity of the projectile motion of the projectile at its maximum height? So we're looking for velocity and maximum height. Those are our two important things. And from what we know about projectile motion is that when something is at its maximum height, it has no vertical velocity component. It only has its horizontal component. Just shown like this. Imagine if we have a projectile that's launched from here and then ends up here. We know that the vertical velocity will slowly decrease as gravity's acceleration takes hold of it and pushes it back down after its maximum height. However, the horizontal component should stay the same because we ignore air resistance and all other factors that may lead it to slow down or increase. And thus, we can see at its maximum height here, we only have this rightward arrow. And that directly links to D. We can do it by a process of elimination as well. We can get rid of A and B, of course, because there is no vertical or horizontal, vertical up and down component. And C is just a combination of two vectors in the X and Y direction, so that would definitely not make sense as well. So D is 100% the right answer. Question 2. Two stars were observed from Earth. Their spectra is shown with the wavelength in nanometers. We've seen this a million times, as long as you've gotten up to this part in your course. Using these spectra, what can be concluded about the motion of the stars relative to Earth and their chemical composition? So, two important things. The motion of the stars relative to Earth and the chemical composition. That's what we're going to be looking at and trying to find out. So let's look at the chemical composition first. And from what we know about kind of the spectra released from atoms of certain types of chemicals, is that each different element or chemical will release a different set of wavelengths, specific wavelengths, like this one shown, or this one, or this one, based on the energy levels of the electrons and how much energy they gain and release. And they are unique to each atom and each element. So helium will be different to hydrogen, hydrogen will be different to lithium, etc. And therefore, we can see that because they are all equidistant, they're just slightly off center to each other. You can see they're kind of diagonally across. One is more shifted to the ultraviolet wavelength and the other one's more shifted to the infrared wavelength, that they should have the same chemical composition. So the same or the same. Therefore, we can get rid of C and D, and now we can just move on to the motion of the stars relative to Earth to pick the right answer. Now, what we know from the Doppler effect is that if a star is coming towards the Earth, we see a slight blue shift. And if a star is moving away, we see a slight red shift. But from here, this perspective, it doesn't really matter whether it's blue shifted or red shifted. All that matters is there is this slight variation in the wavelengths, even though they are the same chemical composition. Either this has been shifted towards the blue shift, or this has been shifted towards the red, the infrared. And therefore, we see that the motion relative to Earth is different because they're slightly off each other. Therefore, it's B. It can't be A because it's not the same. All right, question 3. Geiger and Marsden carried out this experiment to investigate the structure of the atom. Which diagram identifies the particles they used and the result they initially expected? Okay, so we got to be careful here. Which diagram identifies the particles they used and the result they initially expected? because we know that if they use the alpha particles, we know it's alpha particles, so we can get rid of these two. But this is the result that occurred. This is the result they expected. So it is C. So they used alpha particles, so these two are right. However, the result they initially expected was this kind of all the particles would go through. Whereas what actually happened is that some deflected slightly, like this one, and some deflected more than a 90 degree and came kind of back towards them. Okay, question 4. 4 stars P, Q, R, and S are labeled on the Hertzsprung-Russell diagram. We've all seen this one before. Which statement is correct? S has a greater luminosity than Q. No, it does not, because it's below. It's kind of that distance between them. R is a blue star, whereas S is a red star. R is a blue star, S is a red star. No, S is a white dwarf, and R is a supergiant. So R could definitely be blue, but S is most definitely not a red star. It'd be a white star. S has a higher surface temperature than R. This could definitely be correct, yes. Let's just check on D because we know these two are wrong. And if D is wrong, then we can do it by elimination. P is a more advanced stage of its evolution than R. So P is a main sequence. R is a supergiant. Therefore, P is actually younger. Therefore, this is wrong. It should be the other way around. R is at a more advanced stage of its evolution than a supergiant. And therefore, this white dwarf, S, has a higher surface temperature than R. It's because white dwarfs are very condensed, but they're still very hot. And yes, it's therefore C. Okay, so here the diagram shows two coils wound around a solid iron rod. Initially, the switch is closed. Okay. Opening the switch will cause the galvanometer pointer to remain at a constant reading, move from a non-zero reading to a zero reading, move from a zero reading to a non-zero reading, where it remains, move from a zero reading to a non-zero reading, then back to zero. So, when the switch is closed here, the galvanometer should be reading nothing because there's no change in magnetic field in this circuit. Therefore, an induced current cannot be created in this because we need a changing magnetic field, a flux, a changing flux. So, when the switch is opened, there is a change in flux because this magnetic field created because it's a solenoid diminishes, it goes away, it goes to zero. And therefore, there should be a change, a quick change in the reading as a current is created in this solenoid. So we know that this is wrong. We know that this is wrong. We know that zero reading is correct. We know that the zero reading initially is correct. Then to a non-zero, as this is quickly taken off. And then it should hop back to zero. So it is D. Yeah, thanks guys for watching. I didn't realize it was going to take this long to go through these multiple choice questions. I think we'll do 5 per episode and that will work out well.